Hey, thanks for joining me in the shop again. Today we're going to take a look at 12-volt automotive relays, why you might need them, how to hook them up, how they work, and how to diagnose them when they don't work. Now a relay is just basically a switch, but instead of being controlled by your finger, it is controlled by a magnetic field. So when you apply power to this coil, it will pull two contacts together and make the connection. Now, why would I even need a relay? I've already got this perfectly good switch on my dash. I can just hook it right up to that, right? Well, not necessarily. It really comes down to what kind of contacts are inside of your switch and how much load they can hold. Now, this switch is only rated at about 5 amps. So running anything bigger than that off of this is probably going to melt the contacts out of it. That's where the relay comes in. So this relay is rated at 30 amps, and all we're going to do with this switch is power this coil, which only takes a few milliamps, to pull these contacts together, and that way the relay really takes the load. Some of these have 4 pins and some have 5. The 4-pin one only has one function. If you apply power to the outer 2 pins, which on this relay are labeled 85 and 86, it will close the contacts between 87 and 30. Now 30 is the common. Keep that in mind for this relay, because this one has a center pin. There again, there's 30, which is the common, and right now it's closed to 87A. So this middle pin and this pin 30 are closed together right now. Now if I apply power to the outer 2 coils, the outer 2 coil connectors, it will drop its connection between 87A and 30, and it will close the connection between 30 and 87. Okay, let's pull the cover off of this relay and see what's going on inside. Now with the cover removed, we can actually see the contacts and how they correspond to these 3 in the middle here. These outer 2, again, are only for the coil. That's what triggers the relay. So we're going to focus on these middle 3 right now. This one is the common. This is connected to the wiper in the middle. That's this little copper piece here. Now there's a contact on each side of that, on the right and the left. Now the one on the left here you can see is actually triggered. Even though there's no power flowing through this coil right now, it's touching between 30 and 87A. So 87A is the middle one, and 30 is the top one here. Now this outer one is 87, so we're going to apply a little bit of power here. And you'll see that now the relay is active, and it pulled this middle contact over towards this side. Again, this is 30 and this is 87. So now 30 is connected to 87 on the bottom. Now if we turn it back off again, now this one and this one are connected. One more time. Now this one and this one are connected. Alright, so we got to see the 5-pin relay work. What about that 4-pin relay we had earlier? Well, as you can see, it is missing 87A in the middle, which is this outer one here. So this relay will not have this pair of contacts on the outside. So there is no normally closed contacts in a 4-pin relay like that one. We're going to draw a simple schematic showing how to power a fan with a relay. First thing we're going to do is run battery power straight to a fuse, out of the fuse down to pin 30. Now this wire should be a little bit heavier since it is going to carry the load of the 30 amp, 20 or 30 amp fan, whatever you seem to have. This one, for example, is going to be a 20. Okay. Also in this example, we will not be needing pin 87A. Now if you have pin 87A, that's fine, just disregard it. The relay is the same otherwise. Now we're going to hook up our fan to pin 87. And then we're going to swipe some power off of this fuse here to power one side of our relay coil. And on the other side, we're just going to use a simple switch for the dash here So here's my switch for the dash. Here's a couple pins coming out the bottom. This one, we are just going to ground it to chassis. And this one goes right through the firewall, through a nice grommet, to pin 86. This way, when you flip this switch, it's going to make a contact between the ground and pin 86, and because we have power on 85, it is going to activate the relay, connecting pin 30 to pin 87, applying power to our fan, which is grounded to the chassis, and the fan should run. The reason I like this setup is because we are not applying any power through the firewall. We're just applying a ground. So worst case scenario, if this were to rub through and short out on the firewall, it's just going to activate our relay and turn the fan on. With the S10LS conversion project, we're using the PCM to trigger that relay instead of a switch on the dash. The PCM has a pin on it that pulls to ground once the engine reaches a certain temperature. Now if you suspect that your relay is bad, there's nothing wrong with just grabbing another one and putting it in the receptacle. As long as it has the same amount of pins, stick it in there and see if it starts working. I mean, most of the load is put on the relay anyway, so it's not unlikely that it is the relay itself. But if you've tried that, or you don't have another relay to put in there, there's a few tests we can do at the receptacle to make sure that there isn't something else going on. Okay, what you're looking at here is the fan control relay and receptacle for the S10LS conversion. Now this is actually a really good example of why you need a relay in this application. Now just like we talked about before, with a push button or a switch on the dash that's low current, you could trigger a relay off of it, but this one is going to be controlled with the computer. Now the computer can't sink a whole lot of current, so you can't hook the fan directly to it. That's where we need a relay. So the computer is going to ground one of the two outer pins, and that's going to trigger the relay because the other side is connected to a fuse in the fuse box. Okay, the way I have this connected now is one lead is connected to one side of the coil and the other lead is connected to the other side of the coil. Now we're going to ask the computer to turn the fan on, and you should see voltage across those two terminals at that time. Now if you had this relay pushed into that receptacle, you should hear a click. If you don't, that tells you there's something wrong with the coil inside the relay. Now we're going to focus on the relay contacts. That's going to be pin 30 and pin 87 here on the bottom. I've moved my ground from my meter to the chassis ground now, and we should see feed power on pin 30, which we do. That is, this pin here has power from my fuse box. So when this relay triggers, it should put power from pin 30 to 87, which is out here. And right now, of course, I don't have any power there because there's no relay in the receptacle. Okay, so I've pushed the relay back down into the receptacle a little bit, just so we can do some testing at the base of it. I still have my ground hooked up to the chassis ground for the meter, and I've got a nice little pin here that we can stick in. So the relay is not triggered right now, so we should see power on 30. This is pin 30, that's the feed to the relay contacts. And this one we should have nothing because that is pin 87, that's not connected right now. Now if we trigger the relay on, we should see voltage on pin 87. And that is headed out towards our fans. The reason they're not running right now is because I disconnected them so they wouldn't be so loud. But that shows you that that relay is working correctly. It turns on and off and we have voltage out of the correct pins. I hope that helped shed some light on relays a little bit for you. As always, I appreciate you guys joining me in the shop again. And until next time, thanks for watching.